Alright guys, the last section, is dealing with problem solving. So I did tell you that 34 is just like, I don't think you have a problem where it gives you just the median. It's just like in the sense that you have to kind of work backwards or do some problem solving to fill in the missing part. So the median basically is your average of your bases, and bases meaning average, add the two bases, divide by 2. So that's why I was telling you here we just do the median because we know what the average is. It's the 24 times the height. And your height is always going to be perpendicular. So this one we just do 24 times 20, and we should have got 480 meters squared. Okay. This is more like the test. Like one of your answer choices will be, can you tell me how it affected the change in the area? Now, I know it says directly proportional to the length and the size, meaning both the sides are being changed the same time, same amount. But really what you need to find yourself is, first, always find your scale factor, okay? Now, it will either be given to you or it is your ratio from the new to the original, okay? In this problem, the scale factor is your number that you're being multiplied by. So it says the perimeter of the square is multiplied by 4. So that, the second thing what you need to remember is that for perimeter, the perimeter is always the same, has the same scale factor. I'm going to do SF for scale factor. So my scale factor is 4, okay? For area, whenever you have area, you have to square the scale factor. Whatever the square factor is, you square it. So I'm now taking this 4, I'm squaring it, I get 16. This is which represents the change in the area. The area is now multiplied by 16, okay? If I wanted to physically work this out, this is when I would write the proportion to see it, okay? But if you know what the scale factor is, then just square it for area. That's the key. Understand it. Square is for area. It stays the same for perimeter. All right, so if I'm given the area, okay, and I look at the ratio of those areas, remember it's a new to original or second to first, so 22 over 88 can be reduced to 1/4. That's the area of just this is the ratio of just the areas. So to get to the scale factor, I have to now take the square root of that. Well, the square root of 1/4 is 1/2. So basically, the way this figure is changing is everything's cut to half. So if I have 10, half of that would be 5. If I wasn't too sure, x over 10. And then we would see 2x equals 10. Half of 10 is 5. All right, well, you know how to. You could do that mentally. I'm not worried about that. Okay, 37, which is not test light. Let's go through this. So let me just explain it to you. Probably a good thing for some problem solving. All right, did we see that tick marks tell me something? So 6, 6, and 6, and then, so if I'm looking at this triangle, everyone, hopefully you see that that's isosceles. Okay, 6, 6. All right, also, something else you should know. In a kite, only the short diagonals are bisected, okay? So, right here, the diagonals are perpendicular. So this is 45, this is 45. So if I want to get to my diagonals, I got to work backwards and basically say, I'm going to put this as y, okay? Y is basically the hypotenuse divided by square root of 2. So the hypotenuse is the 6. If I was looking at this triangle right there, 6 divided by the square root of 2, you can't keep that, square root of 2. So you rationalize it. So it comes out to be really 3 square root of 2. Well, both of these sides are 3 square root of 2. I'm going to change that y to what it is, 3 square root of 2. Remember, the diagonals are perpendicular. So right here, this is a right triangle. It's not a special right triangle. It's just a regular right triangle. But I have two parts. I have the hypotenuse and the leg. So let's say I'm going to label this now x, okay? So to find that part, I can see that doing the Pythagorean theorem, I'm going to end up taking the hypotenuse, squaring it, subtracting from the other leg, squaring that, Okay, and then taking the square root of that. Always do your exponents first, so I have 100. I want to recap this because see, remember what happens when you square a radical. This becomes 9. 3 squared is 9, and then when you square the square root of 2, we get rid of the radical sign. So this is really going to be 9 times 2, which is 18. So this is 100 minus 18. Then I'm taking the square root of that, which is 82. And that cannot be simplified. So this side right here is the square root of 82. This other remaining diagonal over here is the same as this one, so that's 3 square root of 2. Alright, so the diagonals that we use for a kite is the whole diagonal. So if I'm talking about the whole long diagonal, diagonal 1, that's the 3 square root of 2 plus the square root of 82. You cannot add those together, they're not like terms. If I do the short diagonal, that's 3 square root of 2 plus 3 square root of 2. I can add these because they both have the same radicand. So this ends up being 6 square root of 2. Okay? That's for the diagonal 2. Alright, now, everyone understand the square is just 36, 6 squared. What I'm now having to do is add the area of the kite. So I said square plus kite. So I'm going to do, to get the area of the kite, you're going to need to do this with me. Because this is multiple steps. Area of the kite is diagonal 1 times diagonal 2 divided by 2. Alright, now, one of the diagonals is 6 root 2. That's our short diagonal. The other diagonal is the expression 3 root 2 plus the square root of 82. No, you're not going to have this on the test, but don't stop. Keep pushing yourself. Make sure you know this is a good test to see can you do your multiplying the radicals correctly. Can you distribute? Can you simplify? So we take those. I forgot we got to take half of that because it's half. All right, whenever I multiply 6 root 2 times 3 root 2, that's 6 times 3 is 18 times just the 2. So that gives me 36, okay? Then I'm going to do 6 root 2 times the square root of 82. This is going to be 6 square root of 164. Well, that can be simplified to, I believe it is 4 and 41. Yeah. Yeah. Okay, so this is a perfect square. So this ends up becoming 36 plus, make sure that's right, 12 square root of 41 divided by 2. All right, when I take half of that, guys, I can take half of 36, I can take half of 12. So really I have 18 plus 6 square root of 41. So that's my area of my kite plus my 36, which is my area of my square. And that is my final answer. Okay, it's an expression. Oh, no, forgot. We can combine those. Those are like terms. Those are whole numbers. So it ends up coming to be 54 plus 6 square root of 41. Sorry about that. That's your final answer. That's your exact answer. All right, then last couple problems. 40, wait, did I do this right? 36. I'm missing 37. Oh, here we go. We'll do it here. That was 37. Here's 38. Scale factor squared for area. So 1.5 squared is 2.25. And so if I want to find the new area, the original is 140 times the 2.25. How it's changing? 315. We talked about this one in class. This is not a test like. I'm not really going into more detail because basically the scale factor is 5, but you have to take the square root. That's the scale factor for area. The square root of that is your original scale factor. Because we're doing diagonal times diagonal, in order to get 5 multiplied by 5, you have to do square root of 5 times square root of 5. I know many people had questions on that. All right. The radius of the big circle is 12. So that means the big circle is 144 pi, 12 squared, or pi r squared. All right, so I'm going to look at it like this. So if this is my center, and that's 12. And if I go this way, that would be 12. But look at this. If I divide that up into 1, 2, 3 parts, that means this has to be 4, 4, and 4. So that means the radius of one small circle is 4. So that area is going to be 16 pi. And then how many circles do we have? We have 3. So that's 48 pi. So I take the 144 pi minus the 48 pi. That gives me 96 pi. On 41, I think the easiest way to do this is to draw, like close this up and take this part out. So if I close up this figure and do the parts that I'm taking out, the whole thing would be, this is, if I do my sides, this is 7 by 2, 3, I add it all together. That ends up becoming 7, 2, 3, and 3. That's 15. I do this one the same way. 3, 2, and 2. That becomes 7. So the whole thing is a 7 by 15. And then I'm taking out, well, 7 by 15. I'm going to end up taking out the 3 by 2, or the 2 by 3, another 2 by 3, and then the 2 by 8. And the 3 by 4. I'm taking all of that out from the 7 by 15. Wait, yeah, the 7 by 15. So basically, this is the 105. And then I have what, 6. And this is 16. And that is 12. 24. And that's what, 40? Wait, 12 and 12, 24. Yeah. It's minus the 40. And we get 65 units squared. Okay, that's the remaining shader. All right, and then on 42, I think this is in the wrong order. There it is, 42. I'm missing another page. I apologize. Where are you? Go back, please. All right, this is out of order. So here's 42. 42. Where are you? There you are. Okay, so remember, scale factor. Boom. Dealing with area. What do we do to that scale factor? We square it. So we're dealing 1/4. I'm going to find the area of the new. This is the new one. This is the one that is actually getting smaller. So I'm going to do 1/4. The smaller one is what I'm trying to find. Over 16. Cross multiply. You should get B. That take care of that. And then the one that I'm missing, which is this page, 43. Same thing. I look at the change between the sides to get the scale factor. That's 10 over 20, which is 1/2. Again, I'm looking at area, so I have to square that. That means 1/4. Write my proportion. 400 is the large one, ABC, the original. So everyone see it got smaller, so the 400 goes here. X goes on the top. D is our answer. And then here, which equation can be used to determine the area of the composite? This is an 8 by y. And then we know this is y. This is x. This is a trapezoid. This just should have been h. All right, so there is your video explanation. Make sure you look at your notes, your quizzes, and the problems in your spiral. Thank you.